In this lesson, we'll continue our study of applications of derivatives to consider extreme values of functions. First, let's talk about what we mean by extreme values of functions. Extreme values of functions are just maximum or minimum values. Now, there are two types of maximum and minimum values that we'll study. We'll study global or absolute maxima and minima, and we'll also study what are called local or relative maxima and minima. We'll define these precisely in a moment, but first let's get started by looking at a picture to illustrate these definitions. So an absolute minimum or an absolute maximum occurs. An absolute minimum is when there's no smaller value of f anywhere on the graph, and an absolute max would be when there's no greater value of f anywhere on the graph. So absolute max means the largest overall value of f, absolute min means the smallest overall value of f. We can also have local maxes and mins, and a local max is where there's no greater value of f nearby. So in an interval containing this number x equals c, this is the maximum value of f, but there is an overall larger value over here at x equals d at this absolute max. Similarly, local min means there's no smaller value of f nearby, or in an interval containing this x value x equals e, there's no smaller value nearby, but there is, of course, an overall smaller value over at this absolute min. We have another local min over here at x equals b. Again, it's not an absolute min because there's a smaller value over here at x equals a. We also call absolute mins and maxes local as well. So an absolute is both an absolute and a local, because if we look at our absolute min at x equals a or absolute max at x equals d, it's also true that there's no smaller in the case of a or larger in the case of x equals d value nearby. So absolutes are also local, locals are not also absolute. So let's go ahead and give the formal definitions of these. So for the absolute extreme values, if f is a function with some domain that we'll call D, we say that f has an absolute maximum at a point x equals c if f of c is greater than or equal to f of x for all x values in our domain D. So f of c is the absolute largest value of f of x anywhere in our domain. Similarly, f has an absolute min at x equals c if f of c is our smallest value throughout the domain, or if f of c is less than or equal to f of x for all x in our domain D. Next, we'll define our local or relative extreme values. Again, we're going to have a function f with domain D. We say that f has a local max at a point x equals c if the value f of c is greater than or equal to all values f of x in some interval or just some region around x equals c. And similar for local min, we have a local min at x equals c if f of c is less than or equal to f of x for all x in some interval around x equals c. So here's our formal definitions, and again, you should be able to understand the ideas here with our graphs. So for example, at x equals c, so the point c, f of c, we know that this is a local maximum. There's no greater value of f nearby, or this is the greatest value of f of x in this interval containing c, but there is an overall larger value. So again, the two definitions that you should understand from this first lesson are on global or absolute maxes and mins and local or relative maxes and mins.